Hey, well, welcome everyone. Today, we're really excited to have you to talk about this bicyclist versus right turn vehicles or right hook cyclist crashes. We're really excited about this study, and it's focused on trying to optimize design based on conflict risk data. So I'm Amanda Pushka. I'm a road safety engineer at MicroTraffic, and I'm joined by my colleagues, Craig Milligan and John Lauer, who have road safety backgrounds as well. And Craig's the CEO and co-founder of MicroTraffic. Today, we also have some speakers. I guess if I share the outline for the presentation today, Kristen Norback from UNC and Dylan Passmore from the City of Vancouver will both be joining us and speaking a bit about their thoughts and background when it comes to this problem. We're also going to talk about some study benefits, research design, and study mechanics, and then Q&A. But before we get into this action-packed 60-minute meeting together, we'd like to start off with some poll questions. We're using a platform called Menti. So if you don't mind navigating to www.menti.com, and you'll see here, there is I'm sharing it on the wrong screen here. I might have to stop sharing just for a moment here. And there'll be a code. Okay, now let's get back here. So hopefully you see this code, www.menti.com. There's a code 90167878. And if you go on your handheld device, or if you go onto your computer in a separate browser tab, you should be able to access this. And as we start to see some inputs, we'll see some population. So we're just curious about the demographic of who's joining us today. It's great to see some input come in there, and please keep this menti.com tab open because we have a few other questions as we carry forward here. So great, yeah. I'll just give it another minute here. It looks like we have, a decent spread, but a good number of cities and a couple states. So great. So the next question we have is just related. We're talking here today about bicycle safety, but we're curious about some of the biggest safety challenges that you're facing, your agency, in terms of safety. And this should develop a word cloud so you can actually type in any answer you might want, and inputs and responses that receive multiple answers will get bigger on this slide here. So if you want to put any thoughts you might have for the biggest challenge that your agency might face when it comes to safety. So here we go. We're starting to see some inputs come in, automobile speeds being one. There we go. So speeding, yeah, there's been a lot of talk about speeding in some of the latest ITE sessions that I've attended as well. Distracted driving, yep. Great. So obviously, as road safety professionals, and we have lots of things to think about and be aware of, but thanks for the input there. I'm just going to go to the third kind of icebreaker question. This is surrounding conflict data and near miss analysis. So central to this study is using conflict data. And so we're curious about your experience and understanding of conflict or near miss data. So have you heard about it before? Have you not heard about it? Just interested to see what are some of the thoughts with conflict data. So great, yeah, have some somewhat new people to conflict data. And always happy to see that there are some people who there's nobody that did not find value in the data. So that's great. Okay, so thanks so much for participating. Please keep Menti open. We're gonna have a couple more follow-up questions. And I'm gonna pass it over to Krista to share some thoughts on this road safety issue that we're facing.
Great, thank you, Amanda. So my name is, I've got to first figure out how to do the screen share. I'm gonna work on that first. Okay, you can see it now?
Yep.
Great. So My name is Krista Nordback. I'm a senior research associate at the Highway Safety Research Center, and we've been studying bicycle and pedestrian crashes for decades. My work started about 10 years ago in bicycle-specific crashes. So we're going to talk today mostly about right hook crashes. And I have a video here from the Pedestrian and Bicycle Information Center, which we host at UNC. It's a place where you can find all sorts of information about bicycle and pedestrian issues of all sorts. And we've just created this series of videos about different crash types that are common for bicyclists and pedestrians. So I'm just going to try to play a little clip of this, and this is really just so that I know that you all know what right hook crashes are, but so if you have colleagues that aren't familiar with this crash type, you can point them here. It's a free resource, and they can see what this crash type is and get a perspective on it. So I'm just going to try to play a little clip here, if I can. So that's our crash type that we're concerned about. And they also have
view of a right hook crash.
Different views from the driver and the bicyclist perspective, so people can really see what this type of crash would feel like. Okay.
A driver view of a...
So we're gonna now go on to the next slide, but that's available on our website if you want to share it. So another resource we have is the pedestrian and bicycle crash analysis tool. And that's been used for the last 20 years to crash type different bicycle and pedestrian crashes with motor vehicles. So we know that this right hook crash, which is called the motorist right turn same direction crash in our typology, is the third most common for a city, a college town that use this typing methodology. It's 14% of crashes at intersections. In this college town is about 100,000 people. So even in places that are very bicycle friendly, this is a very common crash type. The good thing is that it tends to be lower severity than some of our crashes. So that's good. But it's still something we're really concerned about because it's so common, and 1 in 9 of these crashes can be fatal and severe in that particular city. The state of North Carolina also used this crash typing, so we can say that it's the 4th most common intersection fatal and severe crash type in North Carolina. So that's pretty big, 6% of the fatal and severe intersection crashes in the state. And it's also, when you look at fatalities, using the FARS data set across the United States, it's the 7th most common fatal bicyclist intersection crash. So intersection crashes are a little less common than road segment crashes, but still 4% of these crashes, it is a very important crash type for us to study and understand. So there have been some studies looking at what will improve, what will remediate this problem. I worked on NCHRP 926 on guidance to improve pedestrian and bicyclist safety at intersections, free, available to the public. And we came up with all these 14 highly effective separating remediation techniques for separating and the motorists and bicyclists, or for reducing speed at these type of crashes. So I'm not going to read this whole list, but you can see. And these are not really based on research as much as just common sense and experience and practitioner practice. So we really need to do more research to understand what is the best and most effective. And we have many research methods. Ideally, we would be able to use crash data to understand what is causing and what is the right treatment. But fortunately, we don't have a lot of bicycle crashes, so that's good. But it also means we can't really use that data type to study the before and after and the treated, untreated type scenarios for coming up with our crash modification factors for each of these potential treatments. So We look at other ways to study it. Driver simulators, microsimulation, surveys of users. What did the driver think who was going through this? What about the residents who use this intersection? And then video conflict studies, which I think we're going to talk a lot about here. And there are two important ways of doing that manually and automated. And I'm sure we're going to talk about the automated, but I want to say some things about the manual approach to watching video and recording manually all of these conflicts, because that is what we as researchers at UNC and my colleagues at Portland State have been doing quite a bit of. And you can see the student there. Actually, that's an employee, a temp employee who's doing it. It's very labor intensive. It takes a huge amount of time. When you're talking about qualitative hazard rating, there's of course some human bias there. When we have post-encroachment time, time to collision, these are quantitative metrics that can be used to measure how close the two vehicles were, and we can do that manually. So that requires a huge amount of time from our students or staff to reduce. So sometimes 1 hour of video may take 3 hours to reduce that. So doing this automated would save a lot of time and allow us to do a lot more studies and increase the number of the N value, the explanatory power of our statistics quite a bit. And it would also keep the poor students and staff from burning out. So this is really important, and I have high hopes. But right now we're still using the manual approach because of issues with accuracy. We want to make sure we're getting the right numbers. So driver simulator studies, there's some of that, and that's been used to look at the eye motion of people driving, and we've found some things. Turning vehicles yield to bikes, reducing the curb radii. This is the work of the folks in Oregon. So there are some proven, or so no, I wouldn't say proven, but at least these are directions that we might go for solving this problem. Leading bicycle intervals, exclusive phasing when you have high bicycle volumes, and mixing zone treatments can separate. Here's the bicyclist, and the bicyclist would then cross the right turning traffic prior to the intersection. So this mixing zone is a way to deal with these types of crashes, but they cause some confusion. This particular one in this study from Oregon, from Portland State University, shows that this is a little more, a little better in terms of the pavement markings. So there has been some studies, and this one does use the video-based conflict analysis with the huge number of student hours needed to do that study. So I will turn it over to others. Thanks so much. And if you have questions, let me know, because unfortunately I do need to leave before the end. Sorry.
Thanks, Krista. Dylan, if you're able, do you have a screen that you want to share? You can take over control here to send some thoughts.
Sure thing. Hi, everyone. One sec as I get going here. Okay. Don't worry, I'm not going to go through all these slides. Yeah, so, okay, so hi everyone, I'm with the City of Vancouver and in the Transportation Design branch. And I just want to give a quick snapshot of just some of the design trade-offs that we're struggling with around this particular conflict. So in Vancouver, as probably a lot of you know, we're working pretty hard to expand out our AAA or our all ages and abilities network. And so it's a lot of this, you know, fully separated, protected bike lanes. Of course, the challenge is, well, what do you do when you get to the intersection? So this is one of it was the first intersection that we did where we came in and retrofitted with more of a protected intersection type design. This is at the bottom of Burrard Bridge where it meets Cornwall. So it went from this to this, which we've presented on many times at other conferences. So some of you are probably sick of hearing about this intersection, but it's just kind of interesting. You know, we really tried to bring in a lot of our, a lot of the thinking around protecting people biking all the way, you know, up to initiating the crossing, right? So there's that having that full protection all the way to where you initiate your crossing, but also that places the cyclist in this advanced stop bar position. It also has the benefit of reducing the pedestrian crossings, which is a bit of a nuance that, probably not going to get into today. But then, related to that right turn, it gives you an opportunity to really tighten up that turn radius in the corner there. There's opportunities to improve sight lines between the motorists and approaching cyclists. And it gives that cyclist making the left turn, full protection through, as they wait to then proceed to make that second stage of their turn. So there's a lot of benefits to that, and we've been getting really good feedback. I'd say though, a lot of the questions that we're really struggling with as designers is when you get into some of the nuance, and you don't necessarily have all the space that we see in some of these beautiful artist renderings, conceptual drawings. So, one of the questions that we really are sort of wrestling with is, especially when we're talking about permissive turns, which this diagram implies, what permissive or what turn volumes are acceptable when we have permissive turns allowed? At what point do we really need to push hard to have full phase protection between through cyclists and turning motorists, and be accepting the delays that come along with that? And then there's these questions around this sort of that lateral offset between the turn bay and the approaching cross bike. The Crow manual, for example, talks about 5 meters, and that's typically what we target, but we can't always achieve that. So, what is that, that appropriate lateral offset? And sometimes, which I'll talk about in a minute, we're choosing to install a right turn bay instead. And sort of when would we prefer a right turn bay versus that lateral offset? So I just want to give you a flavor for some of the design questions that we're struggling with, and then maybe just show you a couple of quick examples. So this is one where we have a one-way couplet downtown that we kind of road dieted, and we converted from 4-lane to 3-lane cross-section with a protected bike lane. And our initial implementation, we did a kind of a not so great, I'll say, mixing zone. It was really short right turn bay. This is telephoto, so it looks a little more squeezed than it was in reality. But we just found that drivers weren't really understanding it. A lot of them were actually making that right turn not from where we had intended in this sort of mixed right turn bay, but in fact from the turn lane. So there's a bit of confusion. It certainly wasn't the most comfortable either. So we actually went back and came back and a couple of years later and redid that approach with an actual proper right turn bay. With, you can't tell from the photo, but the bike lane is actually raised up about 4 inches here, and so that full protection all the way up. And I know this has been a really hot topic in the US, because I believe the MUTCD doesn't allow for this currently. So that's a whole other conversation, but this is an uphill direction. We actually installed the similar similar configuration on the other pairing of this one-way couplet for the downhill. And that's where I think it's been a really noticeable benefit to have that right turn bay. You have the a bit of pressure taken off the right turning motorists, but also a lot more clarity to the approaching cyclist of the attentions of that driver. So this is like a thing, that sometimes we're just sort of stuck having to do, and we don't have enough space for like a fully protected corner or a fully protected approach. But we only to date have collision data around how well this is working. And these kinds of things come up over and over in a lot of our designs. This is a recent 10th Avenue project where we have relatively low right turn volumes here, around 40 in the peak hour. And so we've been allowing that to run permissive. We actually have the left turn is protected for reasons I won't get into right now. But, it was, again, just sort of like, are we comfortable running that permissive right here in light of the volumes and space constraints that we're dealing with? And then we also have this location, it's Quebec and First. Again, I think we've presented on this a few times in the past at other conferences, but basically it was our opportunity to implement through some development that was happening in the area, that sort of prototypical protected intersection. So this is what it actually looks like in the field. And I'll just point out, like, you can kind of actually see it here. It's quite a queue. those right turn volumes are actually fairly high. They sort of vary between 200 and 300 during peak hour. And we had this big debate around, how to be accommodating that. And so in this example, we actually introduced a right turn bay. In so doing, we didn't achieve that full 5-meter lateral offset. That's sort of that ideal. And so it's running permissive. Turn volumes are fairly high. And so there's just sort of a lot of question marks around, like, is this okay? We introduced that right turn bay, though, to future-proof for the possibility of providing that protected phase. So that option is there, luckily. But yeah, it's sort of just, you can kind of see, so this is the approaching cyclist perspective. That lateral offset's 3 meters. You can sort of tell, I think I have another, yeah, you can tell in this shot here, it's really not until the vehicle is at that 5-meter mark that there's really sort of an opportunity, especially in a vehicle of this type, like for that motorist to actually, be able to see down the approaching bike lane. So there's a lot of sort of geometric questions that we have. And, we've been building out quite a few of these types of intersections. So I think this study, it's been a really interesting opportunity to do a deeper dive into, kind of the conditions that we have around the city. And so, some of the things that I've sort of flagged already that we've been hoping to look at through this study is the impacts of turn volumes. There's also conditions where we are allowing permissive rights across a bidirectional cross bike. So what are the impacts of unidirectional versus bidirectional in terms of safety? Then there's these issues I sort of been mentioning of sort of trade-offs between having a right turn bay versus how do you deal with no right turn bay versus that lateral offset. There's another example where there is no right turn bay, and this is where we have the lateral offset. And then, phasing, of course, sometimes we feel pretty strongly that we need protected phasing, but then you can get into some nuance like protected permissive. When could that maybe be appropriate versus permissive? And then, I don't know if we're going to get into this much through this study, but there's just been a lot of ideas rattling around, when we are stuck with permissive phasing, what maybe is there something that we could add to the signal equipment like we have seen in Europe. And then there's an example in the bottom left there that is from Portland. What could be added to just give that extra warning to the turning motorists that to be careful, there's an approaching cyclist. And we actually have an example in Vancouver area. It's not the city's jurisdiction, but where a kind of RFB has been installed with a sensor. You can sort of see it right here that detects the approaching cyclist to trigger the RFB style lights to warn that right turning motorist. So that's just to give you a flavor, I think, of a lot of the design trade-offs that we were, dealing with in Vancouver around this particular conflict. Hope that was interesting.
Thanks, Dylan. I'm sure a lot of people on the call today have dealt with similar issues and how they can start to handle some of these treatments and protect cyclist safety. So I'm going to take control back of the screen again. We're going to go back to another poll question, just given the transition from Dylan's topic. So I see that it must have been left open, so some of you got ahead here and provided some answers, but we're just curious about, Dylan said a few questions that he has, but are there other questions that you've struggled with answering? I'm just curious to see your thoughts on it. Yeah, definitely the right turn only lane is probably pretty prominent right now in the United States, especially with METCD changes that are upcoming. Again, with some protected phasing. So yeah, great. Obviously, it's a difficult thing to handle. And thanks for your feedback there. So now we're going to transition into some of the more content here, talk a bit about the study benefits. I'm going to pass it off to John to share some of the thoughts on the study benefits here. Thanks,
Amanda. Yeah, my task is to discuss study benefits with you. And 3 of them come to my mind. Those include benefits to your agency, to the broader transportation profession, and to your career. So let's start with to your agency. you've got the ability to pick 10 locations in your city. And if your agency is anything like the one where I spent 20 years as the traffic and transportation manager, it's pretty common that you get complaints or reports of unsafe conditions. Those can come from cyclists, they can come from motorists, they can come from adjacent businesses, but what they all have in common is that they're based on opinions. Opinions developed from the human eye perception of distance and speed. And that's not the best way to judge near misses. You can now respond with detailed risk diagnostics and confirm where actual problems exist and proactively address them. In the next slide, you can see an example of the information that will be provided to you. Here you can see by hour of day the times when there is the experience of a low risk or a medium risk near miss, or high or critical. Right turn vehicles are going to be slower in speed, so the majority of these are going to fall into the low or medium categories, but it's all about improving the safety of the bicyclist to grow that mode share. And in the next slide, you can see a less safe operation than what we're looking at now. And you can see a lot more of near misses throughout more hours of the day in this slide. So that's the operational intelligence that you're going to get at the 10 locations that you submit for inclusion in this study. And that gives you the ability then to set priorities as you put your agency's budget together to provide the countermeasures to improve bicycling safety. Next slide, we'll talk about the benefits to the broader transportation profession. You're going to be a part of identifying preferred design treatments. And you also will be decreasing agency liability for bike crashes. What we're doing by you contributing your 10 locations to a approximate 200 site study is to build a professional toolbox. And that's going to be available to the transportation profession to counter opinions with facts. In the next slide, we've got a couple videos, and those will contribute to a larger database with understanding of vehicle-cyclist interactions. We'll be able to quantify the impacts of various treatments depending on the cyclists and the right turn volumes, which will be collected as part of this study. And in the next slide, I think is a great example where if you look at two similar intersections, they both have right turn bays or right turn pockets. And on the left, it is a protected vehicular right turn arrow versus on the right, it is protected permissive. And the data is telling quite the story here. That is that the protected right turn signalization had twice as many hours of analysis, yet the protected plus permissive operation resulted in 5 times or more the number of near misses. So that is operational intelligence that goes from study to being practice ready in implementation of safety measures. In the next slide, the third benefit is to your individual career. You're going to be involved in a study that not only will help shape the profession, but to answer what has been a hot topic over the last couple of years. We've seen a large amount of research on the issue in question, and that's going to continue. You can help by contributing your 10 intersections to this larger study so that we get quantitative design guidance for practitioners to improve cycling safety. I want to conclude by noting that tomorrow is, I'm calling it Infrastructure Day, because the Biden administration will be in Pittsburgh and will start rolling out their ideas for the infrastructure bill. I think what we can expect to hear is that the Build Back Better effort was going to definitely include modal equity. So that's good news for us bicyclists. And also hear that the road to Vision Zero is going to have bicycles on it, in addition to connected and autonomous vehicles. So that as this study after study progresses, we're going to see the interaction of bicyclists with connected and autonomous vehicles. And you can be part of that, making that interaction safe. So I strongly encourage you to participate in this effort. And I'm done.
Craig, do you want to jump in here on some of the research design?
I will. Yeah, thanks, Amanda. I couldn't remember if there was another Menti question. Those things are so fun. They're so much fun. Yeah, my name's Craig. I'm a road safety engineer with MicroTraffic, and I want to tell you a little bit what we hope to answer with this database. So if you go into the next slide, Krista mentioned some of these recent efforts, but she also talked about how either they're using limited crash data or unrealistic time expectations on students to review video, and they end up putting in the design guidance things that reflect collective wisdom, and there's a real desire to say, you know what, we need to validate some of that stuff and even take some of that collective wisdom a step further in kind of fine-tuning the answers to some of the questions that, say, Dylan brought up. I mean, Dylan was on the committee or a co-author of NACTO and came up with the intersection, and he's coming out of that effort with questions. And so when we heard about that, we said we want to help build the database, but we need your help to do that. So our goal here is to provide this community database that can just take all of these research efforts to the next step. And NACTO can have it, every NCHRP panel can have it, every university can have it, and so on. If you go to the next slide, Amanda, when City of Vancouver came and said we want to investigate this problem, they said, Dylan helped put together this matrix and said, there's all these questions about how these different facility types are performing. And one of the key things we want to do is kind of fine tune this matrix with a larger group. You know, there's 45 cities, there were 49 earlier on this call, and puts a bit more collective wisdom into this matrix, finalize it, populate it with everybody's participation so we have a decent sample size and can really build this cross-sectional database across a lot of different facility types. So it's a cross-sectional design. If you go to the next slide, Amanda. We just finished the video analytics for locations in Vancouver, and we have 27 conflict locations where we observed for about 3.3 days each. There was 4 days of video recording, but some of the video had to be rejected. Records of 27,000 vehicles and 116,000 right turning, 26,900 cyclists, and you see 116,000 vehicles. So I want to talk a little bit about the global graph that came out of this. And on the vertical axis here is the number of conflicts per day. So whatever we saw in the 3.3 days or 4 days, or whatever, normalized to the number of days. And the bottom axis is the cross product of vehicular traffic and the right turning volume. And if you go to the next slide, Amanda. The first thing we noticed is that there's pretty striking correlation between cross product and conflict frequency at a 52% R squared. That's like with one explanatory variable, it's explaining a lot. This value often is kind of talked about as a percentage explanatory power on the outcome. So we're about half of the variability in conflict is explained by the cross product. So that speaks to Dylan's question, at what cross product do you put in protected phasing? But the other interesting thing to us is the other half, the unexplained variability, the 48%. And why are some conflict counts, you can see, way above the line of the average conflicts per day given the cross product, and why are some below? There's additional variability here that's not explained by the cross product. And this other half, we think the factors that explain this variability can be discovered through research and then controlled for through design, okay? And to illustrate what I mean by that, if you go to the next slide, I just made up these ovals, okay? But if we discover a group with a common set of design parameters, okay, and we discover those factors that put them in that group, and we discover another set with common design parameters or operational characteristics in the good group, we want to basically release that information to the research community to start building out design practices to say, it's a fact of our current reality that we rapidly expanded bike mileage, or you guys did, by 600% in the last decade. And in doing it, we built a lot of facilities above the line, a lot of facilities in the red group. And what we're hoping to unlock from this is kind of two opportunities. We can learn to more accurately design future cycle lanes so that they perform more like the green group than the red group. And we can learn ways to retrofit the red group facilities that we already built to shift their future safety performance into alignment with the green group. Can you go to the next slide, Amanda? So one could be like physical design characteristics, but another thing that could come out is operational related warrants, and Dylan alluded to that. So we saw right here at 400,000 daily cross product, we may not land on that eventually. Maybe we use hourly peak hour cross products like he was talking about. But if you have a strategy like prohibiting right turns or using protected right turn phasing, both are kind of costly strategies in terms of spending your political capital and operational capital, and because of the delay to vehicular traffic, right? So we hope that data coming out of this study could maybe support evidence-based warrants, could emerge from that. NACTO could come around that, NCHRP groups could come around that, or even city by city could say, here, based on the data, we can control, even if it has to stay in the red group because we can't retrofit it, we can control it to below 5 conflicts per day if we use protected right turn phasing or something like that. So just kind of separating out where the cross product or other operational factors lead to spikes in conflict counts. There's a lot of other research questions we hope that the community can pick up and answer with this kind of repository that we're going to build together. How can connected and automated vehicles form context-sensitive conflict and crash avoidance strategies? More detail on distinguishing serious and non-serious conflicts, the relationship between conflicts and injury counts. We're going to take the injury count, crash counts at every location, and have a 200 site conflict versus injury collision prediction model. We recently did conflict to injury collision prediction model that got a 94% R-squared for left turn versus opposing crashes, for vehicular crashes, and published in January in TRR. And we'd like to get the same kind of thing. So not every conflict is equal. And the ones that are more serious have a stronger, in that one, we subdivided the conflicts into serious and less serious based on kinematic factors like speed, and also temporal factors. And we found the more serious ones had a 3 times more powerful prediction on the future injury count. So that's kind of a bit of what we hope to accomplish through the research. I'll pass it back over to you, Amanda.
Great, thanks, Craig. So one final question here that I want to kick off for the poll and Menti, and here we go. So just, we talked about a number of treatments. We're curious if there's any ones in particular that you're interested in quantifying the safety benefits of. So you can vote for as many as you'd like. Oh, there we go. So yeah, some quick build input there. I know there's been a lot of push for that in some more recent times. Great, yeah. So thanks a lot, and feel free to keep putting in those answers. We'll take a look at that after as well. So I just want to take a few minutes here to quickly talk through some study mechanics. A lot of you have received a one-page summary document that we provided, but we'll just talk through a few other details here today before we get to Q&A. So first off, with the technical steering committee, Kristen Norbach and Dylan Passmore, 2 members on our committee. We're also joined by Taha Salim, but we're currently recruiting for other technical steering committee members. So if this is something that you're interested in, please feel free to reach out and contact us. The technical steering committee will help provide the technical input and establish the finalized site matrix for analysis. Craig showed the draft one there, but we want to expand it for this study. This committee will provide advice throughout the project duration and meet every 2 to 3 months to discuss the project progress. And then we hope to participate, have all the members participate in a post-study webinar to help share the findings and the results with the public. So some participant information, there is it's a pooled fund here. It's a participation fee of $30,000 US, and that includes the analysis of the 10 locations. We will work with the participants to help select those locations to fit within that finalized site type matrix. And we hope that the agency will provide 5 to 10 years of collision data, attribute data, and any volume data if available. But yeah, 5 years of data of collision data may not be sufficient, so we may need up to 10 years. And then lastly, the agency is responsible for collecting between 3 to 7 days of video footage at each location. And the duration of video collection is a function of the right turn volume and the cyclist volume as well. So we'll work through those questions. There are a couple of different options for video footage collection. So temporary cameras such as Malvision Scouts can be deployed, or permanent cameras that are nearby may be able to be used as well. So we can certainly explore those options with you. Feel free to email us if you have specific questions, or if there's general questions we can get to during the Q&A, that works as well. There are other video collection plans possible for an added fee if you want to have someone else responsible for collecting your video. Just wanted to quickly summarize the project outcomes again. So first off, each participant will obtain the detailed conflict safety information at 10 locations in their jurisdiction. So John talked about that detailed temporal data and risk level data. So each participant will get that in their local agency. Secondly, the full 200 site comprehensive right hook database will be accessible to all participating cities to help enable more of a proactive or quantitative design guidance, which can really help to improve any of the high risk locations that you've identified in your city. Third, the database can be leveraged to develop a practitioner design guidance resource and for subsequent studies that Craig touched on. And finally, we expect publications and public webinars at the study completion to help to shape the profession with this database. For the proposed schedule, we are interested in launching this project in the very near future. So we have some deadlines here. We expect to have an expression of interest or intent deadline in a couple weeks time, so on April 15th. So just we will be following up this webinar with a survey, and there'll be some options on there. So if you have an intention to participate and have the required funding, or if you are just interested in the study and need to look into budgetary approvals, we will follow up with you if you're interested to book a meeting to discuss where you're at. But if you're intending to participate, that's great. We'd like to best case launch this project right away. So please let us know. And if you are not able to participate, please also let us know. So this expression of interest or intent deadline, we're hoping by April 15th. And we understand that contract finalization may extend beyond this, but we will be sending out that survey. So please keep an eye out for that. By May 1st, we hope to form the technical steering committee and finalize the site type matrix. That will enable video collection to occur during the summer months when cyclist volumes have increased. So between May and August is what we expect. And then following the video collection will be the video analytics. And And of course, this is impacted by the video collection schedule, but it'll be complete by December 2021, but we do expect to be prior to that. And then also the research analysis will be ongoing throughout the process, but expected in early 2022. So please keep an eye out for that follow-up survey and the expression of interest deadline. And if you're interested in joining the technical steering committee, please also reach out. And for those of you who said they'd never heard of conflict data before and want to set up a meeting with us and learn a little bit more, please also reach out here. We have all of our contact information for Craig, John, and myself. And then I have Krista and Dylan's contact info there as well if you have questions specifically for them. But I think at this time we have about 10 minutes left to open it up for any questions. So if people want to put it in the chat box, or if there's a way to unmute themselves, I don't know, Craig, this would be a good chance to ask any questions that we can apply, and we can certainly follow up with anyone directly.
I'm going into the participant thing. I see Charlie Wilson has a hand up. If anyone wants to ask a question, try to use the raise hand feature, or if that fails, send us a chat, then I'll press a button that says allow to talk. And then we'll go like that for the Q&A. So I'm going to go with Charlie. I've given you permission to talk, Charlie, but you're still muted.
Hi, can you hear me?
Yes.
I'm not. I did that by accident. Thank you. This is a very informative presentation. I'll let other folks ask questions. I didn't mean to raise my hand. Sorry about that.
Okay. The next raised hand I see is from 1+6. So I've clicked on allowed to talk, and please let us know who you really are. Unless you were named by Elon Musk, and then that's your name, 1+6. You got to take yourself off mute.
Hello, good evening.
Okay. Hello.
My name is Leila Mushanga, and I'm contacting you from Europe. So I'm here based in Copenhagen, and I would like to thank you up front for the great presentation you've carried out. And well, I'm completing a PhD in the field of road safety, and I found your presentation quite interesting. I was wondering whether to participate as a member of the steering committee, it requires that you are also applying for the project participation, or is these two separate things? Just to clarify. Thank you.
It's membership is possible for like research institutions, so it sounds like you're at a university, and we'd be happy to
Yes.
talk to you more about that. But generally, it's from the participating cities. Yeah.
All right, more from the community. Yes, because yeah, that's something that we could have a discussion in another point, because I am owner of a company that also conducts with research studies regarding this. So yeah, so that I'm interested to see if maybe you would be interested in transferring it, the type of studies to other regions, for example.
Thank you. We look forward to discussing more with you. Yeah, please contact us by email after this, or we have your email, so we'll contact you.
Yes.
Amanda, I see some questions in the Q&A section, and maybe I'll read those out. Maybe I'll ask this one to you. I see Roger Geller. Questions about the yellow and green indications for conflicts in John's slides. Portland State University Green Lane study found most conflicts were precautionary. They also identified minor, substantial, and major collisions or conflicts. Where did the yellow and green fall on this scale? Or, I mean, Amanda, would you like to speak to the concept of measuring severity levels and even the goal to refine those severity levels through this?
Sure, yeah. So right now we look at different temporal indicators for, Krista mentioned PET. We look at an indicator called T2, which is a time to collision indicator. And we looked at events that are less than 3 seconds in proximity. So other agencies can look at larger durations, but the less than 3 seconds is something that we start to study that now become perhaps less, oh, I see the question disappeared here, but less severe than maybe a benign interaction. The speed is another critical property of this. We look at, of course, as John mentioned, the right turn speeds are somewhat lower. And yeah, so both the speed and the temporal separation come into play when we look at and classify the severity of interactions. So I saw the question isn't here anymore. So Craig, is there any other thing you want to add to that?
There's different ways to define the severity, and just that I think it's very important to experiment with those, find the ones that are the best predictors of injury risk, using, of course, kinetic energy-based fundamental principles. Same commenter, Roger, asked about the minimum number of, as soon as you answer it, it's gone. The minimum number of jurisdictions. So we think to really make this contribution to the study, we've set it as 200 intersections. So it's 20 jurisdictions at 10 intersections per. You can increase to 20 intersections for a jurisdiction too. It's just, or 15. The participation fee is going to be proportional to, if you want to double your participation fee, we do double the number of intersections from your jurisdiction. But we probably wouldn't go beyond that doubling because we want Canada, US distribution and a good cross section of cities participating. So I'm looking here for additional Q&A or hands up. I don't see any hands up. Okay, Amanda, do you want to take this one from Scott Bohemian?
Sure, yeah. Also keep an eye on the chat pod too, Craig. Some questions are in there, I think.
Okay.
But for the Q&A, so how long would an agency have to collect the video data? So yeah, we kind of alluded to that. We're looking at between the 3 to 7 days, but as I mentioned, it's a function of the volume of right turning vehicles and the cyclists. We want to make sure that we have a good representation of events and a good sampling size there. So it'll range depending on the volumes there. If you hopefully have some volumes at that location, otherwise we can try to work with you to figure out a video collection plan, but we're looking between the 3 to 7 day mark right now.
Mm-hmm. Yeah, the Vancouver initial sites were very informative for that. So like let's say that it's a site that happens to average based on the cross product, we'd expect 2 conflicts per day. Then if you measure for 5 days, you're going to expect 10. And you can now see if that one is drifting up higher or below 10 with some statistical significance. But we don't want to measure for 1 day a site that you only expect 1 per day, because you're going to either see 0, 1, or 2, and not really, that's a large percentage fluctuation. Listen, on the chat section, I see Dylan, a question about the link to the recording. And Amanda, maybe you take that together with the link to the survey. And
Sure,
then we'll
yeah.
come back to Scott's clarification. So I'm going to send everyone an email right after this.
Mm-hmm. Yeah, we have been recording this session, so we can send a recorded link to it if anyone in your agency was unable to attend. We will also send a survey that we can look at with a number of questions, including your expression of interest. We will follow up again with that, hoping to receive that information by April 15th, I think it was.
Yeah. Scott, just a little point on that. That survey is a Google form. It's not a contractual obligation, but we'd love for you to just ask whoever you need to ask. If you don't hit too many roadblocks in that and you get a yes, a preliminary yes from them, just log in with your intent on that Google form. If you do need more time, let us know. We don't really want to move to April 15th, but you know, we'll deal with reality if we have to. Scott clarified how long to collect all sites, how many cameras would have to be installed to complete the task. So this is going to depend. You could have different strategies, right? So if it's 3 days per site and you have you need one camera per site, because we're just looking at the bike lane. If we were doing, sometimes when we do a full intersection diagnostic, which is what we usually do at MicroTraffic, a diagnostic and a safety improvement plan and a follow-up risk reduction analysis, we'll have maybe 3 or 4 cameras on the intersection. But this one just needs one, looking at that one particular conflict area. And so if you own one MyVision Scout camera, then it takes 10 weeks to collect the video. And that's going to be fine. We're not going to be able to process it all, you know, in one shot anyway. So if you take 10 weeks, if you have 5 cameras and take 2 weeks to record it, most of your cities also, you know, there'd be a company like NDS or some other similar company. You could call them. Maybe your traffic counts group already has a contract with them to put up takedown video cameras. So some people own their own, some people use contractors for this. Yeah. Let me see. Yeah, I see a comment in the chat from Marianne. I acknowledge that. Thank you for joining. For that particular situation and all their situations like yours, that's kind of why we're doing this, and want to bring data to support all kinds of safety improvements, whether it's stuff to prevent truck on a ride or other types of crashes, which can happen at the same time as right turn crashes, usually, actually.
I don't see any other questions here in the chat or Q&A, but please feel free to reach out. I think you have our email address information through the webinar link, but if you have any questions following up after, I'd be happy to answer them or meet with you one-on-one if you have questions.
Yeah, that sounds great. When we email you the video link, if you know of a city that you think you don't know if they were on the webinar or not, and you think, oh, I have a colleague in this city, it would be great, they shouldn't be left behind, feel free to email it out to them, right? Okay. Thank you everyone very much for your time.
Thanks.
Thank you.